This is lesson 2-3, multiplying and dividing rational numbers. First, we're going to talk about some properties. The identity property of multiplication says for every real number n, 1 times n equals n, and n times 1 equals n. Let's look at a couple of examples for that. For instance, 1 times negative 5 is still negative 5. Also, negative 5 times 1 is still negative 5. We know that no matter what number we multiply by 1, it'll still be that number. The multiplication property of 0. For every real number n times 0 equals 0, and 0 times n equals 0. So any number we multiply times 0 will always give us 0. For example, 35 times 0 is 0. Also, 0 times 35 is 0. Any number we multiply times 0 will always give us 0. And the multiplication property of negative 1. For every real number n, negative 1 times n equals negative n, and n times negative 1 equals negative n. So for instance, negative 1 times 5 equals negative 5, and 5 times negative 1 equals negative 5. So multiplying by a negative number changes the sign on your other number. Negative 1 times a positive 5 gave us a negative 5. Positive 5 times a negative 1 gave us a negative 5. When you multiply a number times negative 1, it changes the sign of that number. And now we have two rules before we start into our lesson. Multiplying numbers with the same sign, this rule says the product of two positive numbers or two negative numbers is always positive. So that just means when I multiply a positive times a positive, so for example, if I have a positive times a positive number, then my product is positive. If I multiply a negative number times a negative number, then my product is still positive. So as long as they both have the same sign, your product is always positive. Multiplying numbers with different signs. The product of a positive number and a negative number, or a negative number and a positive number, is negative. So when the signs are different, the product is always negative. For example, 3 times negative 6 is negative 18, or negative 3 times 6 is negative 18. When they have different signs, a positive times a negative is always a negative. A negative times a positive is always a negative. When they have different signs, your answer is negative. When they have the same sign, your answer is always positive. Let's apply that to example 1, multiplying numbers. Simplify each expression. So we have a negative times a negative. They both have the same sign, so our answer is going to be positive. 11 times 3 is 33. On B, we're multiplying a negative times a positive. They have different signs, therefore our answer is going to be negative. I know I can put my whole number over 1. 6 times 3 is 18, divided by 1 times 4 is 4, and that's an improper fraction. I want to change it to a mixed number. My answer is still going to be negative. 4 goes into 18 4 times, and that gives me 16. So we have 2 left over out of 4. And then we can simplify negative 4 and 1/2. So 2/4 simplifies to be 1/2. Negative 4 1/2 on example 1. Okay, let's look at the quick check. Again, we're following that rule. So we're multiplying. They have different signs, so our answer is always negative. 4 times 6 is 24. Multiplying, they have the same sign, so the answer is positive. 5 times 10 is 50. Here they have different signs. Negative 4 and 9/10 times, negative 4 and 9/10 times negative 8, they have the same signs, so our answer is going to be positive, and I'm going to multiply this off to the side. 4 and 9/10 times 8. 8 times 9 is 72, carry the 7. 8 times 4 is 32, plus 7 is 39. We have one number behind the decimal, so I have one number behind the decimal. Since they're both negative, my answer is positive 39 2/10. Remember that when they have the same signs, both negative or both positive, your answer is always positive. And if they have different signs, then your answer is negative. So let's look at the last one, D. Negative 2/3 times positive 3/4. They have different signs, a negative and a positive, so my answer is going to be negative. And they're fractions, so just multiply across. 2 times 3 is 6. 3 times 4 is 12. Negative 6/12, which we can simplify to be negative 1/2. Example 2, evaluating expressions. Remember that evaluate just means solve, but we have to substitute first. So my original problem is 5RS. We know that when there's no sign in between a number and a letter, or between two letters, that the only sign, the only operation that's possible is multiplication. So we're really just multiplying 5 times R times S. So when I substitute, I know I'm multiplying 5 times R, which is negative 18, times S, which is negative 5. Remember that parentheses are also multiplication signs. So since all we're doing is multiplying, the order doesn't matter. You can multiply 5 times negative 18 first, or negative 18 times negative 5 first, or negative 5 times positive 5 first. What matters, though, is what's our sign? Is our sign going to be positive, or is it going to be negative? Well, let's look at the different ways we can multiply these. We could multiply 5 times negative 18 first. They have different signs, so that would give us a negative number. Then we would multiply this negative number times our negative 5, which would give us a positive number. Okay, well, you might be saying, well, that's just if you multiply it that way. What if you multiply it a different way? What if we multiply negative 18 times negative 5 first? That's a negative times a negative. They have the same sign, so our answer is positive. And we multiply this positive number times another positive number. So no matter the order you multiply these in, you're always going to end up with a positive answer. The reason for that is you have an even number of negatives. Remember that a negative times a negative is always going to give you a positive. And then, of course, a positive number times a positive gives you a positive. But here, we'll just work it this way so I can show you. 5 times negative 18. So 18 times 5. 5 times 8 is 40. Carry the 4. 5 times 1 is 5. Plus 4 is 9. So a positive times a negative, that's negative 90 times negative 5. Now I have a negative times a negative, which gives me a positive. So I'm multiplying 90 times 5. 5 times 0 is 0. 5 times 9 is 45. So we get 450. And you'd still get positive 450 even if you multiplied it in a different order. Let's look at these quick checks. So again, we're evaluating, which just means substitute and solve. So I have the opposite of C times B. So C is negative 8 times B, which is negative 7. And I have to follow PEMDAS here, which tells me we need to simplify the parentheses first before we deal with this negative outside the parentheses. So I have the opposite of negative 8 times negative 7. A negative times a negative. They have the same signs, which means my answer is going to be positive. So 8 times 7 is 56. And then this negative out here really just says the opposite of whatever you get in here. So since we got a positive number inside the parentheses, that means my final answer is a negative 56. When you have a negative outside the parentheses like that, you can think of it as the opposite of whatever's inside. Inside was a positive, so the opposite of a positive 56 is a negative 56, and that's our answer. On B, again, we're substituting negative 2 times negative 3 times, and remember that this is just C times B. When there's no sign, we know it's multiplication. So C is negative 8 times B, which is negative 7. Now, we do kind of have to follow PEMDAS here. Since we did group together C and B, they're inside the parentheses together. So I'm going to go ahead and multiply those first because of the grouping symbol. But you'll notice we have 1, 2, 3, 4 negative numbers. We have an even number of negative numbers. So our answer should come out to be positive. And it will, because again, a negative times a negative, that would give you a positive, and this negative times a negative is going to give us a positive. So when we multiply the two positives together, we will, in fact, get a positive. Let's see that worked out. So I'm going to leave negative 2 times negative 3 alone. And negative 8 times negative 7, and negative times a negative gives me a positive, so it's a positive 56. And now, again, it doesn't matter what order you multiply in, so I'm just going to multiply negative 2 times negative 3. I like to work left to right. So I'm going to multiply negative 2 times negative 3 together. And a negative times a negative, again, gives me a positive 6 times 56. So notice we ended up multiplying two positive numbers together because a negative times a negative gives us a positive. These negatives multiplied together give us a positive, so we end up with these two positives. And I'll just multiply this off to the side. 6 times 6 is 36. Carry the 3. 6 times 5 is 30 plus 3, 336. And it's a positive 336. On C, C times negative B. So again, we're substituting first. C is negative 8. Remember that you can also read this as the opposite of B. So I'm going to leave it. Bring down my negative. and B is negative 7. So it's the opposite of negative 7. Remember, when you have that double negative, that it creates a positive. The opposite of negative 7 is a positive 7. So I'm going to change them both to positive signs. So now we have a negative 8 times a positive 7. Now they have different signs, a negative and a positive, so our answer is going to be negative. 8 times 7 is 56. Example 3. Use the expression negative 5 5/10 times A divided by 1,000 to calculate the change in temperature for an increase in altitude A. So altitude A is altitude of 7,200 feet. Remember, these word problems are really very simple. We're really just interested in any equations or expressions they give us and any numbers they give us to plug in. So all I need is negative 5 5/10 times A divided by 1,000. And what is A? Well, they told us in the problem A is 7,200, so I'm going to substitute. So I have negative 5 5/10 times 7,200 divided by 1,000. I'll start by simplifying so we can cancel those zeros. And then 72 divided by 10, if I had $72 and I divided it by 10 people, I would get negative 5 5/10 times 7 2/10. 72 divided by 10. You can do that off to the side. You can do it in your calculator. 10 goes into 72 7 times. 10 times 7 is 70. Bring down your 2. We can't continue unless we add a decimal and a 0, so I'll add a decimal. Bring down the 0. 10 goes into 22 times, so we get 7 2/10. That's where the 7 2/10 came from. And now we just need to multiply. A negative number times a positive number always gives us a negative. And then you can just multiply those off to the side. 5 times 2 is 10, carry the 1. 5 times 7 is 35, plus 1 is 36. 0 placeholder, get rid of that. 5 times 2 is 10, carry the 1. 5 times 7 is 35, plus what is 36? 0, 6, 9, 3. And we have 2 numbers behind the decimal, 2 numbers behind the decimal. So it's a negative 39 6/10. Or 39 60 hundredths, either way. Example 4, simplifying exponential expressions. Use the order of operations to simplify each expression. This says the opposite of 2/10 raised to the 4th power. B says negative 2/10 raised to the 4th power. I'm sure you've noticed by now the difference is B has parentheses, A does not have parentheses. We know that the exponent just means take this number and multiply it times itself that many times. So we're going to do that. But again, since there are no parentheses here, this is really read as the opposite of. So the opposite of whatever 2/10 times itself 4 times would be. B has you raising negative 2/10 to the 4th power. So it's negative 2/10 times itself 4 times. So it's negative 2/10 times negative 2/10 times negative 2/10 times negative 2/10. Do you see the difference between these two? Again, A is really read as the opposite of 2/10 raised to the 4th power. So you're just going to multiply all this out, and your answer is always going to be negative. It's the opposite of all this multiplied, so our answer is negative. On B, though, everything is raised to the 4th power, the negative included. So it's negative 2/10 raised to the 4th power. Everything's raised to the 4th, so it's negative 2/10 times itself 4 times. So let's look at A first. 2/10 times 2/10. 2 times 2 is 4. But we have 2 places behind the decimal, so I have to add a 0 and a decimal. And then I multiply that times another 2/10. 2 times 4 is 8. And now we have 1, 2, 3 numbers behind the decimal. And then multiply again times 2/10. 2 times 8 is 16. And we have 1, 2, 3, 4 numbers behind the decimal. So add 2 numbers, 2 zeros and a decimal. Now I have 4 numbers behind the decimal. So it's, what would this be? Tens, hundreds, thousands, 10,000, 16, negative 16 10,000ths as your answer. On B, it's negative 2/10 times negative 2/10 times negative 2/10 times negative 2/10, because again, it's inside the parentheses, so the whole thing is raised to the 4th power. So we're still multiplying 2 tenths times 2 tenths times 2 tenths times 2 tenths. We're still going to get the 16 10,000ths, but we need to know what the sign is going to be. So this negative times a negative will give us a positive, and this negative times a negative will give us a positive, and then we multiply the positive times a positive, which will still give us a positive. Remember that when you have an even number of negatives, your answer is going to be positive. And we'll look more closely at that in this quick check. So on A, again, this means the opposite of 4 cubed. So the opposite of 4 times itself 3 times. So it's the opposite of 4 times 4 is 16, times 4 is 64. The opposite of 64, which is negative 64. B, this means negative 2 times itself 4 times. So negative 2 times negative 2 times negative 2 times negative 2. Negative 2 raised to the 4th power. The negative is inside the parentheses, so the whole thing is raised to the 4th power. So we have a negative times a negative, which gives us a positive. So 2 times negative 2 times negative 2 gives us positive 4. Positive 4 times negative 2 gives us negative 8. Negative 8 times negative 2 gives us positive 16. Again, that even number of negatives always will give you a positive, because when you multiply two negatives together, you get a positive. So negative times negative, positive, negative times negative, positive. And we know, of course, that positives always multiplied together will give you positive. C, this is similar to one of the examples we did together. Negative 3 tenths squared means negative 3 tenths times negative 3 tenths, because it's the negative inside the parentheses. The whole thing is raised to the 2nd power. So a negative times a negative gives me a positive. 3 tenths times 3 tenths. 3 times 3 is 9. Two numbers behind the decimal, add a 0 and a decimal. So 900. Last one, the negative now is on the outside of the parentheses. So although we have parentheses, we really don't need them. This is still read as the opposite of 3/4 squared. So it's the opposite of 3/4 times 3/4. And so we keep the negative. Our answer is going to be negative. 3 times 3 is 9. 4 times 4 is 16. So negative 9/16. Okay, now in this part of our lesson, we switch over to talking about dividing numbers, but it's really the same rule as multiplying. Dividing numbers with the same sign, the quotient of two positive numbers or two negative numbers is always positive. So it's really just like the rule for multiplying. Two positive numbers or two negative numbers. Here's some examples. Positive 6 divided by 3 we know is a positive 2. Or negative 6 divided by negative 3 will still give us a positive 2. So when you multiply two positives, you get a positive. When you divide two positives, you get a positive. When you multiply two negatives, you get a positive. When you divide two negatives, you get a positive. And the dividing with different signs is also the same as our multiplication. The quotient of a positive number and a negative number, or a negative number and a positive number, is always going to be negative. So it's the same thing as multiplying. If they have different signs, they're negative. So here are a couple of examples. Negative 6 divided by 3 is negative 2. A negative divided by a positive is a negative. Also, 6 divided by negative 3 would still give you a negative 2. Again, a positive divided by a negative always will give you a negative. So if they have different signs, your answer is negative. If they have the same signs, your answer is positive. Example 5. Dividing numbers. Simplify each expression. So this is a positive divided by a negative, so we know our answer is going to be negative. 70 divided by 5 is 14, so negative 14. You can do that off to the side or in your calculator. 70 divided by 5 is 14. One positive, one negative, so your answer is negative. On B, I wrote it a little differently just to remind you that this fraction bar is also a division bar. So it's negative 54 divided by negative 9. And negative divided by a negative gives us a positive. 54 divided by 9 is 6. Quick check 5. Negative divided by a positive gives us a negative 42 divided by 7 is 6, negative 6. B, they're both negative, so our answer is positive. 8 divided by 2 is 4. C, positive, negative, different signs, so our answer is negative. 8 divided by 8 is 1. and D, they're both negative, so my answer is going to be positive because they have the same sign. 39 divided by 3 is 13. Let's look at example 6. Evaluate the opposite of x divided by y minus 4z squared. Notice I read this as the opposite of x divided by y. It's the same thing as saying negative x divided by y. It means just the same thing. Again, we're evaluating, which just means solve, substitute, and solve. So I'm going to leave everything else alone and only change my letters into their numbers. So x is 4, so I have 4 divided by y is negative 2 minus 4, and this is 4 times z squared. Z is negative 4. And so some people would say, well, what do I do? Is it negative 4 squared? And I put a little time sign, or does it go in parentheses, or what do I do? Well, here's the rule. Anytime you're substituting, that number always goes in parentheses, because remember that we just learned a couple of examples ago that negative 4 squared is different from, or the opposite of 4 squared is different from negative 4 squared. So the rule is that anytime you substitute, it automatically goes in parentheses. That way you know, instead of getting a negative 16, we're going to get a positive 16. Every time you substitute, it always automatically goes in parentheses. So that's why we did it there. And you can put parentheses around these other numbers. It just doesn't change anything. There's really no need for it, but we needed it here because this changes the whole problem, whether or not the negative 4 is inside the parentheses or not. Because it makes the difference between negative 16 and a positive 16. Okay, so now we just want to simplify according to PEMDAS, which says exponents first. So I have the opposite of 4 divided by negative 2 minus 4, and this is 4 times, so 4 times negative 4 squared is 16. And again, we're just following PEMDAS, which says that we next would be, after the exponents would be multiplication, division, left to right. Notice that, again, this is also a division bar, so we have to divide before we can multiply over here. So this is the opposite of 4 divided by negative 2. The opposite of 4 divided by negative 2, a positive divided by a negative, would give us a negative, so negative 2 minus 4 times 16. Notice I kept this negative. Now we're going to deal with it. So it's the opposite of negative 2. Remember that a double negative creates a positive. So now I just have 2 minus 4 times 16. Now this looks much simpler. We'll apply PEMDAS 4 times 16. So I have 2 minus 4 times 16 is 64. And then remember, subtraction is the same as adding the opposite. So we change, adding the opposite. And 64 minus 2 is 62. 64 is bigger, it's negative, so the answer is negative 62. Right here, though, some people have said, well, is it negative 4 times 16? And you could have done that too. So we could have done 2, and we could have done negative 4 times 16, which would have given us a negative 64, so you'd still be doing 2 minus 64, so you'd still be adding the opposite, and you'd still get a negative 62. So either way, if you treat this as a positive 4, then just bring down your minus sign, or if you treat it as a negative 4, you'll still get the same answer. Let's look at these quick checks here. Again, we're evaluating, so substitute and solve. 3, this is 3 times x, so 3 times 8 divided by 2 times z, so 2 times z, which is negative 3, plus y, which is negative 5, divided by 10. And we need to follow PEMDAS. We do have a set of parentheses here. It's grouping 2 times negative 3 together, so that's the first thing I'm going to do, and copy everything else. So 3 times 8 divided by 2 times negative 3. They have different signs. A negative times a positive gives us a negative, and 2 times 3 is 6. So negative 6 plus negative 5 divided by 10. We don't have any more grouping symbols. All these parentheses that are left are just multiplication signs, or just really separating the numbers from other symbols. So now we just multiply, divide left to right. 3 times 8 is 24, divided by negative 6 plus negative 5 divided by 10. And then divide left to right. So 24 divided by negative 6, positive divided by a negative gives us a negative. 24 divided by 6 is 4, so negative 4. Plus negative 5 divided by 10. And then we have to divide here before we move on to adding. Negative 4 plus negative 5 divided by 10. Remember, you could rewrite this as negative 5 divided by 10. That's the same thing. So we know, really, we're just going to simplify this. 5 divided by 10, or negative 5 divided by 10, is just negative half. It's smaller than 1, because if I have $5 and I divide it up between 10 people, they're going to get less than a whole dollar. So it's negative 4 plus a negative half. So a negative and a negative, they have the same sign, so we're just adding them together and keeping the sign. 4 plus a half is 4 and a half. That's A on B. Again, substitute first. This is 2 times Z. Z is negative 3 plus X. X is 8 divided by 2 times Y, which is negative 5. And then we just want to follow PEMDAS, so we'll simplify the top before we move to the bottom. 2 times negative 3, negative 6 plus 8. Divided by 2, and you can simplify the bottom as well if you'd like. So 2 times negative 5 is negative 10. But we have to add these together before we can divide. So negative 6 plus 8, they have different signs. Subtract. 8 minus 6 is 2. 8 is bigger, so our answer is positive. 2 divided by negative 10. And now all we can do here is just simplify. A lot of people want to reverse it and say 10 divided by 2 is 5. But it's not like that. It's really just the opposite. We're going to get a small number. So we'll just divide top and bottom by 2 and get negative 1/5. That's our answer. Last one on C. So substitute first. 3 times Z. So Z is negative 3 squared. Remember that you need the parentheses here since you're squaring it. It makes a big difference. Minus 4 times Y, which is negative 5, divided by X, which is 8. And then we follow PEMDAS, which says do your exponents first. So negative 3 squared. Remember that negative 3 squared means negative 3 times negative 3, and negative times a negative gives you a positive. So I have 3 times 9 minus 4 times negative 5 divided by 8. And we're going to multiply and divide left to right. 3 times 9 is 27 minus 4 times negative 5 divided by 8. And then we have 4 times negative 5, 27 minus 4 times negative 5. A positive times a negative is a negative, so negative 20 divided by 8. Although some people, these are all equal to each other, some people right here would have called it a negative 4 times a negative 5, and that's fine. Then you'd have 27 negative 4 times negative 5 is a positive 20 divided by 8. And you'll see at the end we'll get the same answer, because what we're about to do is say, well, if I'm subtracting a negative, subtraction is the same as adding the opposite. So I end up changing it into plus 20 anyway. So either way, you'll get the same thing. And then we still have to divide before we can add. 27 plus 20 divided by 8. So 27 plus 8 goes into 20 2 times, and that's 16. So there are 4 left over out of 8, which we can simplify to be 27 plus 2 and 1/2. 27 plus 2 is 29, so 29 and 1/2. Okay, a couple more things and then we'll get to our last example. The inverse property of multiplication. For every non-zero real number a, there is a multiplicative inverse, 1 over a, such that a times 1 over a equals 1. For example, 5 times 1/5 is just 1. Or negative 5 times negative 1/5 is also just 1. Because remember that all whole numbers are over 1. 5 times 1 is 5, 1 times 5 is 5, 5 divided by 5 is 1. Same thing over here. A negative times a negative gives us a positive. 5 times 1 is 5, 1 times 5 is 5, 5 over 5 is 1. So when we multiply a number by its multiplicative inverse, 1 over that number, we'll always get 1. The multiplicative inverse, or reciprocal, is where you have a over b or b over a. So for example, 1/3 and 3 would be multiplicative inverses, or 4/5 and 5/4. They are multiplicative inverses of each other. 4 times 5 is 20, 5 times 4 is 20, 20 divided by 20 is 1. Same thing over here. Or maybe you have 2/3 and 3/2. 2 times 3 is 6, 3 times 2 is 6, 6 divided by 6 is 1. These are all multiplicative inverses, so they're just flipped around. They're all the reciprocals of each other. Last example. Evaluate P divided by, remember this stands for divided by, P divided by R, for P equals 3/2 and R equals -3/4. So I'm going to start by substituting. P is 3/2 divided by R, which is -3/4. Whew. Now, a lot of people, when they look at this, they get real concerned. Some people would just give up and say, forget it. But it's really not that hard. We're just going to rewrite it, and then you'll see how much easier it really is. So remember that this is divided by. So instead of writing a division bar, I'm going to use a division sign. So I have 3/2 divided by -3/4. And it's still the same thing. It's the same exact problem. I've just written it, and I've just kind of rearranged it. So we're still dividing 3/2 and -3/4, but I've just written it in a way that looks much less intimidating. So remember, to divide fractions, we have to copy, change, flip. So I copy the first fraction, 3/2, change division to multiplication, and flip the last fraction. That's where the multiplicative inverse comes from, or the reciprocal. We're flipping it over. So -4/3. It's still negative, though. It keeps its negative. And now we can just multiply across real easily. A positive times a negative gives us a negative. 3 times 4 is 12. 2 times 3 is 6. And then we can simplify. It's still going to be negative, but 12 divided by 6 is 2, so -2. How simple of an answer for a problem that looked so complicated. -2. Okay, last one, and then we'll be done with this lesson. X divided by y. We're evaluating the expression for x divided by y. It's the same thing. Substitute and solve. So x is 8 divided by y is -4/5. This looks too complicated. Let's rewrite it. 8 divided by -4/5. You do have to keep it in order. So since 8 is on top, it has to come first. And we know that all whole numbers are over 1. And we're going to copy, change, flip. So I have 8 over 1, change division to multiplication, and -4/5, so it's -5/4. And then we just multiply across. Positive times a negative is a negative. 8 times 5 is 40. And 1 times 4 is 4. And again, we can simplify. Our answer is still going to be negative. 40 divided by 4 is 10, so -10. And that's this lesson. Good luck.